Welcome viewer. This video explains the concept and process of testing hypothesis for z-test for single population. A z-test for a single population is a statistical method used to determine whether the mean of a single population is significantly different from a known or hypothesized population mean. Here are the key assumptions of the z-test for a single population. First, random sampling. The sample data should be collected through a random sampling method to ensure that it is representative of the population. Second, normal distribution. The sampling distribution of the sample mean should be approximately normally distributed. Third, large sample size. The sample size should be sufficiently large, typically n greater than or equal to 30. Fourth, known population standard deviation. The population standard deviation, sigma, must be known. This assumption is necessary because it is used to compute the standard error of the sample mean. Fifth, independence. The observations in the sample should be independent of each other. This means that the occurrence of one observation should not influence the occurrence of another observation. Let's now discuss the steps for hypothesis testing using a z-test for the mean of a single population. First step is, formulate the null and alternative hypotheses. We are testing whether a sample mean differs significantly from this population mean or not. Therefore null hypothesis can be stated as mu is equal to sample mean. Whereas, alternative hypothesis can be stated as mu is not equal to sample mean for two-tailed test. For left-tailed test, alternative hypothesis can be stated as mu is greater than sample mean, and for right-tailed test, alternative hypothesis can be stated as mu is less than sample mean. Second step is, choose the significance level, alpha. Common choices for alpha include 0.05 and 0.01. This signifies the probability of rejecting the null hypothesis when it is actually true. Third step is, determine the critical region. Based on the alternative hypothesis and the significance level chosen, find the critical value or values from the standard normal distribution table. Fourth step is, collect data and calculate the sample mean and standard deviation. Collect a sample from the population and calculate the sample mean and the sample standard deviation. Fifth step is, calculate the z-score. The formula for the z-score is, z is equal to sample mean minus population mean divided by population standard deviation divided by under root n. Sixth step is, make a decision. If the calculated z-score falls in the critical region, reject the null hypothesis. And if the calculated z-score does not fall in the critical region, fail to reject the null hypothesis. Final step is draw conclusion. Finally, interpret the results in the context of the problem and make a conclusion. Thank you for watching. Don't forget to like, share, subscribe and hit the bell.